Okay, so yesterday you have noted down these points. Now we will discuss these. The first point is every polynomial function is differentiable at each x belongs to R. Okay, so in a question, if you will get a polynomial function, then we will directly write it as differentiable. Okay, I will tell you where to use these standard results. Second point, which you have noted down yesterday, is exponential function is differentiable at each x belongs to R. So if in a question you get this one, you get exponential function, we will directly write the result. Next is every constant function is also differentiable. Next is logarithmic function is differentiable at each point in its domain. So the same thing we will do with the logarithmic. Next is trigonometric and inverse trigonometric functions are differentiable. Okay. Next is sum, difference, product, and quotient of two differentiable functions is differentiable. Okay, this you have already noted down. Now, we will try this question. Anyone can tell me that what is the difference between this question and the questions which you have done yesterday? Anyone can tell me what is the difference between the two questions? Please read this question, okay? And then compare this question with the yesterday's one and tell me what the difference between the two. There is the equation, okay, but in last question also, if I will change the slide, so okay, for example, if you will see this question, then what is given? Discuss the differentiability of this function at x is equal to 0. Okay, they're saying that discuss the differentiability of this at x is equal to 0. Now, if we will check this question, then here they are saying discuss the differentiability of the complete function. Okay, so in the previous questions, they ask us to check the differentiability at a particular point on. Okay, so yesterday the questions which you have done, in the question they clearly ask us, yes, you were correct, Omir. So they clearly ask us to check the differentiability at a particular point. Okay, now in these types of questions, they ask us to check the differentiability. Okay, so that means we need to check the differentiability at each and every point. Okay, not any particular point, but at all the points. So check here. If we will analyze this question, then what is given here? If x is less than 1, if x is less than 1, fx is this. If x is greater than equal to 1 and less than equal to 2, we have fx this. If x is greater than 2, we have fx is equal to this. Okay. So in this question, we need to discuss the differentiability at each and every point. So please check here how we need to solve it. For x is less than 1, for x is less than 1, fx is equal to 1 minus x. Okay. For x is less than 1, fx is equal to 1 minus x. So we will write 1 minus x is a polynomial function, is a polynomial function. It's a polynomial function which is differentiable, yes, sir. All polynomial functions are differentiable. Okay. Just give me 2-3 minutes first. I understand your query. Okay. I will explain everything here. 1 minus x is a polynomial function which is differentiable everywhere. hence fx is equal to 1 minus x is differentiable for x is less than. Okay, and if you have any doubt here, then just write this, which is differentiable and suffix. Now, the same thing we have used in continuity. Okay, in continuity, I told you that if there is x is less than 1, then for that the function is continuous. Only where there are chances that the function is not continuous, or in this case, function is not differentiable at these particular points. So at x is equal to 1 and x is equal to 2, there are chances that the function will not be differentiable. Okay, except these 2 points, we will use the standard results. Okay, so at these 2 points, 1 and 2, there are chances that the function will not be differentiable. Other than these, we will write the standard results. Okay, so in this case, for less than 1, can can you use the graph to explain why it will not be differentiable? I'm not saying, Umir, I'm not saying that it is not differentiable. I'm saying there is a possibility. Why? Because if we will draw a graph, I'm just drawing a rough sketch. Okay, so this is 1. So for less than 1, you have this equation 1 minus x. Okay, so just give me a minute. Y0 x1. Okay, so if we will draw the graph of this one for less than 1, you can have like this line. Okay, and when it is greater than equal to 1, then you have another curve. So it is changing its shape. So at point 1 and 2, the graph is changing its shape. For the LHS, you have a different function, and at the right side, you have a different function. So there is a possibility that at x is equal to 1 and x is equal to 2, there can be a corner point. Okay, it is a possibility that there can be a corner point. Because of that, the function will not be differentiable. Yes, there are chances. So this is a rough sketch. This is not the correct one, because the second is quadratic equation and the graph of quadratic is parabola. Okay, so we need to again change this in the standard form, and then we can draw a graph. So that was a rough sketch. That graph is not of this one, but I just want to explain this, that for x is less than 1, you have a different function. For greater than 1, this is a different function. So there is a possibility that at 1 there can be a corner point. Okay, so always in such type of questions where they ask you to check the differentiability at each and every point. So for less than 1, for greater than 2, between 1 and 2, we will write the standard results. The possibility is at 1 and 2 only. So at these points where there's a change in the graph, we will find the LHD and the RHD as we have done yesterday. Okay. Now for x is less than 1, now here we will write for x is greater than 1. We will not take less than, sorry, equal to. Just give me a minute. Okay, so for this one, for x is greater than 1, less than 2, we have fx is equal to 1 minus x, 2 minus x, uh, which is a polynomial function, which is a polynomial function, and it's differentiable. So fx is equal to 1 minus x, 2 minus x is differentiable for x is greater than 1 Okay. Now same thing with this for x is greater than 2. For x is greater than 2, f(x) is equal to 3 minus x, which is a polynomial function, which is a polynomial function, which is a polynomial function, and hence differentiable. So f(x) is equal to 3 minus x is differentiable, for x is greater than 2. Okay. So we have written for these the standard result. Sorry. Okay, now for the point 1 and 2, we will find the LHD and RHD. Okay, now you all already know how to check the LHD and RHD for the point 1 and 2. So please note down this, then check for point 1 and 2 that the function is differentiable or not. Okay, if anyone have a doubt, then please let me know. Otherwise, please note down this and check the differentiability for point 1 and 2 on your own. Zed, you have joined late. Is it clear to you, Zed? Zed, is it clear? Okay, great. So please note down this, check for 1 and 2 and confirm with the answer. Okay, now one thing I need to discuss with you that for LHD, if you are checking for x is equal to 1, okay, for LHD, can anyone tell me which function we will choose? This is first, this is second, and this is third. So second, for one, I'm asking for one, LHD. Left hand derivative means you are no, for that's not correct. LHD for one, I'm saying for very good, sir. That's correct. So if this is one, then we are approaching from the left side. If you are approaching from the left side, then the value will be slightly less than one. Okay, just give me a minute. Okay. So if x is we are approaching to one from the left side, so the value will be slightly less than one. So that's why we will choose the first function. For RHD at x is equal to 1, which function we will choose? For RHD at x is equal to 1, which function we will choose? No, that's not correct. RHD means we are approaching from the right side. Okay, but very, very close to 1. So if we will check here, so this value is greater than equal to 1. So we will choose this value, not third. Third is greater than 2. So the difference is much more. We need to take a value which is very, very close to 1, but greater than. So this one. Now LHD at x is equal to 2. LHD at x is equal to 2. Which function we will choose? LHD at x is equal to 2. Anyone? LHD at x is equal to 2. Second one. Very good. So LHD means less than 2. This one. This. RHD at x is equal to 2. Third one. Very good. This is correct. So please take these functions and complete it. Check for 1 and 2 and confirm your answer. LHD, no, it is not correct. Okay. Please again check the calculation. It is not correct. Anyone else get the LHD at x is equal to 1? No? Okay, I will solve it. LHD, Abdur, very good. Zad, very good. It is correct. Very good. Rifat, please let me know if you have find out the LHD. For LHD, it put x is equal to, yes, that's correct. LHD at x is equal to 1. So the formula is limit x tends to 1 minus fx minus f1 by x minus 1. So for LHD, which function we have to use? 1 minus x. RHD, okay, that's correct. So this is equal to limit x tends to 1 minus x minus f1 x minus 1. Okay. Now put x is equal to 1 minus h, the bracket, right? When x approaches to 1 minus h approaches to 0. So this will give you limit h tends to 0. 1 minus, in place of x, you write 1 minus h minus f1. What's the value of f1? 0. Okay. By 1 minus h minus 1. So this is equal to limit h tends to 0. Open the bracket 1 minus 1 plus h by 1 minus h minus 1 is equal to limit h tends to 0. Cancel out 1, you get a h. Here you have a minus h. So limit h tends to 0. Cancel out this h, you will get a 1, minus 1, minus 1. Okay, Umair, please check the calculation. And Rifat, please let me know if it is done. Z, RHD is correct. All of you, please now find the RHD for x is equal to 1 and share your answer. Okay, Rifat, very good. Rifat, then please find LHD at x is equal to 2. For LHD, Fahad, at x is equal to 2, yes, we will take the second equation, this one. Good. Okay, Zed, good. Then please find RHD. Z, RHD is -1. RHD should be -1 for x is equal to 2. Okay, again, please check it. You should get a -1. Okay. Very good, sir. That's correct. Very good. At x is equal to 1, no, Abdur, it is differentiable. It is differentiable at x is equal to 1. So I have found out this one, LHD. What RHD you are getting, Abdur? RHD at x is equal to 1. What's the value? Uh, no, that's okay. Yeah, that's -1. That's correct. So LHD is -1, RHD is also -1. So the function is differentiable. Okay. Okay, great. Now please check for x is equal to 2 and share your answer, all of you. No, Mir, that's not correct. Okay, please check here. The limit x tends to 1 plus fx minus f1 by x minus 1. That's equal to limit x tends to 1 plus, which function we will choose? This one, 1 minus x, 2 minus x. 1 minus x, 2 minus x. Okay, minus f1. So if we will put 1 here, we will get a 0. So f1 is 0 by x minus 1. Now put x is equal to 1 plus h. So here you will get limit h tends to 0. Okay, in the bracket we will write when x approaches to 1 plus h approaches to 0. Okay, and so here you will get what? 1 minus 1 plus h. Next is 2 minus x. So 2 minus. First, just give me a minute. 1 plus h. Okay, by 1 plus h minus 1. Okay, so first your doubt is for RHD at x is equal to 1. Okay, RHD. RHD means we are approaching this 1. We have this 1. We are approaching this 1 from the right side. Okay, so if you are approaching this from the right side, then the value should be slightly greater than 1. That's correct. First, if we are approaching from the right side, then the values should be slightly greater than 1. If you will check here, then this function is for what? X is equal to 1 as well as for greater than 1. So that's why we need this one. Is it clear for now?
Yes.
Okay, great. Okay, now please solve this. So limit h tends to 0. Open this bracket, 1 minus 1 minus h. Open this bracket, 2 minus 1, 2 minus 1 minus h by h. Okay, 1 and 1 will cancel out. Okay, here 1 and 1 this will be cancelled out. So limit h tends to 0. Okay, here you will get what? Minus h. Here you will get what? 2 minus 1, 1, 1 minus h by h. So this h will cancel out, minus 1. Put this 0. So here you have a minus 1. Here you have 1 minus 0. Final answer is minus 1. Okay. Before putting x is equal to 1 plus h, solve the polynomial is correct. Solving the polynomial, it is better, Umir, okay, that you will put the value, then you will solve it. But let me check what you have done here. Okay, so that will give you the same result here. Yes, please share the pic of this. Okay, this will give you the same result. Here you have 1 minus x, here you have x minus 1. If you will cancel out these two, you will get a negative here. Okay, and minus 1 will be multiplied with this. After that also you will get a minus 1. Okay, Umar, please share the pic with me. I will check it. So now please find for x is equal to 2. Okay. Zed, you have already completed. Abdur, did you check for x is equal to 2? Abdur, did you check for x is equal to 2?
No, sir.
Done?
No, sir. No.
Okay, okay, we're doing. Okay, okay. Okay, then Rifat, for x is equal to 2, did you find the LHD and RHD? Okay. So please complete it, Rifat, and let me know if you have any doubt here. Uh, Next is Fahad and Umair. Please note down this and then check for x is equal to 2. Okay. Oh, okay, Umair, let me check it. Okay. Okay, Rifat, I will change the slide. Okay. Please let me know once it is done. Is it done, Rifat? Okay, okay, great. Umair, you have done mistake while multiplying these two. Okay, please check here. So you have 1 minus x into 2 minus x. I'm writing here 1 minus x into 2 minus x. So open this 2 minus x minus 2x plus x square. So 2 minus 2x, sorry, 2 minus 3x plus x square. Okay. So this is a mistake which you have done. Okay, Umir, please correct it and then check what the answer you're getting. And then please find for x is equal to 2 and share your answer. First, your question is for LHD at x is equal to 2, we have to use third equation because x should be slightly greater. LHD, you're saying about LHD first. Okay. So for LHD, okay, here, suppose this is 2. If you are finding the LHD, that means you are approaching from the left side. Left side means slightly less than 2. Okay, for LHD, for LHD, you will approach from the left side slightly less than 2. Then which function we will use, second or third? First, which one will we will use? Second one, very good. So Umair and Fahad and Rifat, please complete it and share your answer. And Abdur also. Abdur, Fahad, Rifat, Umair, please let me know if you have any doubt in the second part, okay? For x is equal to 2. Good, Abdur, it is correct. For x is equal to 2, LHD is -1. That's correct. Now please find RHD. Abdur, just give me a minute. Let me check it. So you have find out the LHD. So we have this function. Okay. No, it will be 1. Okay, Abdur. For LHD, it will be 1. LHD will be 1 for x is equal to 2. Okay. So you need to select the second function. For LHD, second function need to be used. Again, please check the calculation. It should be 1. I'm please do in the same way. Okay, Abdul. You should get a 1 here. Very good, Rifat. Now please find RHD at x is equal to 2. First, you need to multiply both the brackets. Yes, for RHD, we have to use third equation. But what you have done, I guess you missed to multiply these two. You have missed one bracket, the calculation. So let me solve for you. LHD at x is equal to 2. At x is equal to 2. So this is limit x tends to 2 minus fx minus f2 by x minus 2. limit x tends to 2 minus. Now for the fx, we will use 1 minus x, 2 minus x. 1 minus x into 2 minus x minus f2. If you will put here, you will get a 0 by x minus 2. Next, put x is equal to 2 minus h. So when x tends to 2 minus h tends to 0. Here what you will get? Limit h tends to 0. Okay. 1 minus x means 2 minus h. So first you have done a mistake here. You miss a bracket. 2 minus h by 2 minus h minus 2. So what you will get here? Limit h tends to 0. Open this bracket, 1 minus 2 plus h. Open this, 2 minus 2 plus h by 2 minus h minus 2. So it is equal to limit h tends to 0. Open this bracket, 1 minus 2 means minus 1 plus h. This is h by minus h. Cancel out this. So this denominator negative I'm writing here. H tends to 0 minus 1. Here you have minus 1 plus h. So put the limit. Okay. So what you will get minus 1 plus 0, which will give you 1. So LHD is equal to 1. Now similarly find the RHD. RHD,
So can you show how did you cancel minus h and h?
this one, please check
Yes.
here. Suppose we have 2 by 4 into 2 by minus 2. So I'm writing here 4 into 2 by minus 2. So can we cancel this 2 and this?
Yes.
Okay, and this negative, this will be shift to numerator minus 4. Is it fine?
Yes.
Okay, okay, great. Now please find the RHT, okay? RHT is much simple. Please calculate RHT and share your answer. Rifat, RHT is done. Rifat, you have calculated RHT? Okay, it is one. Very good, very good. That's correct. Okay, then that means it is not differentiable. So Abdur, Fahad, and Umair, please share your answer. LHD I have found out. Please find RHD and let me know the answer. Fahad, you are getting a -1. Let me check. Uh, yes, that's correct. RHD is -1. So we will say that the function is not differentiable at x is equal to 2. Very good. Umair and Abdur, please share your answer. Um, Umir, how can we suppose we have a 2 and minus 2? Good, Abdur, it is correct. Umir, for example, we have 2 by minus 2. Can we cancel out this minus 2 with 2? No, we can't cancel out this negative. If we will cancel this, then negative will remain. We can't remove this negative. We will shift this numerator negative in the numerator. Okay, Umir? Okay. So Umir, please find out the RHD and share your answer. Abdur, your question is how to know when should we use limits and when we use differentiability method. I'm sorry, Abdur, I do not understood your question. Will you please explain? In the differentiability method, we have to use the limits. Will you explain, Abdur? No issue, Abdur. We will discuss this after the class. Okay. Because in differentiability, when to use LHL, RHL, and when to use RHD. Okay, okay, okay. Abdur, in the differentiability, we will never use the LHL and RHL. Okay, in differentiability, we always have to use LHD and RHD. If in the question they are asking you to check the differentiability at any point, you have to use the LHD and RHD concept. -1, very, very good. Omer, it is correct. Okay, Abdur. You will never. Okay. So in differentiability, always use LHD and RHD. Then in continuity, you have the limit. Okay. So in differentiability, we just have a single formula. Okay. We can discuss this after the class if you have further doubts. Fahad, is it done? Did you get the RHD? Okay, okay, you got. Okay, 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 fine. So all of you, you have completed this question. Now, I hope this is clear to you. So if in the question they ask you to check the differentiability at a particular point, at a single point, then you know what the concept. But if they in the question they ask you to discuss the differentiability and they do not give you any particular point, then this is the method which you have to use. The point at which the function is getting changed, there is a possibility that the function will not be differentiable or continuous at that point. So on those points, you have to use a proper method. For the rest, you can use the standard results. Okay. Now, okay, so this question is your homework. The similar type of questions we have already discussed in continuity. So you just need to define the modulus and you need to solve it. Okay. So this question is for the homework. Please note down this. Raise your hands. In case anyone face any issue in the question, then we can discuss in the next class. problem defining modulus I need. Okay, Omer, then after the class we can discuss. Okay.
So can you discuss this now?
Okay. Then what we will do, I will define this and then you can do this question, Abdul.
Yes.
Okay. Okay. So fx is equal to x minus 1 plus x minus 2. We have this one. Fx is equal to x minus 1 plus x minus 2. Okay. Now we will define it separately and then we will combine it because in the question they have given the combination of these two modulus. So anyone can tell me the reference point. I guess we have already discussed how to find that reference point. Anyone can tell me what is the reference point here? Anyone can tell me what is the reference point? For example, mod x we define in this way, x greater than equal to 0. So this is the reference point. Anyone can tell me for this?
So less than 0 and more.
X less than 1.
Less than 1 and greater than 1. That's correct. Always remember whatever the expression you have inside the modulus, equate that with 0. For example, in this question, we have x minus 1. Okay, here. We will equate that with 0. The value you will get, this is your reference point. Okay. So here, x is less than 1 and x is greater than equal to 1. Okay. This is clear to everyone. This is the first step. You need to find this point. Abdur, Fahad, Umair, Rifat, Zaid. This is clear? Okay, Fahad. Okay, Rifat. Abdur, Umair, Zaid. This is clear? Okay, Zaid. Okay, Abdur. Umair, is it clear?
Yes, sir.
Okay, great. So, Umair, please let me know when x is less than 1, what the value we will select here. What I will write here when x is less than 1? Yes, Umair? Sorry, Umair, you are not audible.
So it will be x minus 1.
No, not x minus 1. X is less than 1. So, what we will write here?
So
Anyone?
minus x minus 1.
Very good, Abdur. This is correct. Minus we will write. Minus x minus 1. For example, here, when x is less than 0, we always write minus x. So if x is less than this point, we will write negative. Now, similarly, for x is greater than equal to 1, what we can write here?
X minus.
X minus 1. Okay, we will take the positive value. This is clear?
Yes, sir.
Okay. I hope this is clear to everyone. Now we will check for the next second function. Okay. Now again, who can tell me what will be the reference point here?
So 2.
2. Okay, what the expression you have inside the modulus, equate that with 0. You will get a 2 here. So x is less than 2 and x is greater than equal to 2. For less than 2, what we will write here?
So minus x minus 2.
Minus. Further, always please write bracket. Okay. Minus x minus 2. And for greater than 2, greater than equal to 2,
Plus x minus 2.
plus x minus 2. Okay, this one. Now, but in the question, they have added these two expressions. So we will need to combine this. Okay, please check here. Now, how can we combine it? Fx is equal to. Okay, so here less than 1, greater than 1, less than 2, greater than 2. If we will take less than 2, then there is a possibility some point will get missed. So lowest value is this, x is less than 1. So first we will write x is less than 1. Okay, so I will ask you one by one because we have many options here. So the first question is from Abdur. Abdur, when x is less than 1, then in place of this, what we will write here?
So
Uh,
minus x minus.
very good, very good. Minus x minus 1, very good. And this one, Abdur, in place of this?
So minus x minus 2.
Very good, very good. It is correct. Why it is negative? Please check here. When your value is less than 2, we will use a negative. If the value is less than 1, then definitely it will be less than 2. That's why we will write negative here. Okay, so I hope this is clear to everyone. You can solve this. Open the bracket, minus x plus 1 minus x plus 2. So here you will get minus 2x and here you will get a 3. Now next value. Next is x is less than 1 is done. Now we will take the next value greater than equal to 1. Okay, for greater than equal to 1, the next question is from Umair. Umair, when x is greater than equal to 1, then what value in place of this we will write? Mod x minus.
X minus 1.
Very good, x minus 1. Then in place of this, if anyone have a doubt at this point,
Minus x minus 2.
okay, so if anyone have a doubt at this point, okay, because this is incomplete. So if you think that it is incomplete, I should write something else here, then please let me know. Okay, yes, Samir, what the value we will write here?
So minus x, x minus 2.
Okay, so we are saying x is greater than 1. So there is a possibility that value of x is greater than 1, but can be less than 2. Okay, but there is also a possibility that the value will be greater than 2. So this is incomplete. We have to write less than 2 here. If I will just write x is greater than equal to 1, we can't decide mod x minus 2. Okay, because for x is greater than equal to 1, there is a possibility that your value is even greater than 2. Just give me a minute, okay? Just give. Okay, so when x is greater than 1 equal to 1, there is a possibility that the value is greater than 2. So this will be positive. And there is a possibility that the value is less than 2. So this is negative. Okay. So in this case, we can't decide only with x is greater than equal to 1. So we have to write the third one, less than 2. Okay. Now, Umair, can you tell me what is the value of x minus 2, positive or negative? Umair, in place of this, what we will write? You are not audible.
So what's your question?
Yeah, my question is for this one, for this range, what we should write in place of this mod x minus 2?
Minus x minus 2.
Very, very good. Minus x minus 2. Now open the bracket. So what you will get here? You will get x minus 1 minus x plus 2. X will cancel out. You will get a 1. Okay. So here we will write a 1. Now in the third one, we will just write x is greater than 2 because this is the only option which is left. So I hope the second part is clear to everyone that why we have written less than 2. Because if you are writing just greater than equal to 1, then it is incomplete. This include all the values which are even greater than 2 and which are less than 2. So on the basis of this only, we can't decide the sign of x minus 2. Now x is greater than 2. Who is left? Fahad. Fahad, can you tell me that for this mod x minus 1, for this one, what we will write? For x is greater than 2, what we will write here?
X minus 2.
Very, very good. X minus 1. Okay. For the next one, mod x minus 2, what we will write?
X minus 2.
Very good. Plus x minus 2. If you will solve this, then what you will get? 2x minus 3. Now, is this clear to everyone?
So why we are writing plus and first equation we wrote minus?
Yes. That depends here. That depends here. X is less than 1. Check here. When x is less than 1, what the sign we have to use?
Okay, minus.
Okay. And similarly, when less than 2, what sign we have to use? Negative. If the value is less than 1, then definitely it will be less than 2. Is it fine?
Yes.
Okay. So everyone, please note down this. Please again analyze it. If you have a doubt, then we can again discuss this in the next class. Okay. If you have a doubt, even you can tell me right now also. And this is a very important question because similar type of question we can see in integration also. Okay. So please note down that there's no need to write down this in exam. This you can do in the rough and you can directly write this only. Okay, so please note down this. Now the rest of the question you have to do on your own. Okay, this is similar to the previous one. So please note down this, raise your hand so that we can check the next question. Okay, Abdur, good. All of you, please raise your. Okay, Zad. Okay, Rifat, good. Okay, Omir. 10 minutes is fine. Okay, okay. So we are taking a 10 minutes break. Okay. So we will continue our class after 10 minutes. Please take a walk for 10 minutes. Uh, 4 minutes is still left. Someone was saying anything? Okay, please wait for 4 more minutes, then we will continue our class. Okay, I hope everyone is back. Will you please raise your hands? Abdur, Fahad, okay, Rifat. Thank you. Okay, Zad. Abdur, Fahad, Omir, are you back? Okay, Abdur. So who is left? Fahad. Okay. So all of you, you are back. Okay. So I hope this question is clear to you. Okay. If you have any doubt in the modulus, then please let me know. If you still have any doubt here. No? Okay. Then we have this question. This is also a homework. Okay. Previous one you have to do on your own. This is also a homework. This is a very, very good question. Okay. But you have to do in homework. I need to start a new chapter today. Okay, so this is differentiable. Use LHD, RHD, equate LHD and RHD, you will get all the values. And remember one more property, there is a chances that one more property will be used here. If a function is continuous, it will be differentiable. They are saying it is differentiable. That means it is continuous also. So you can use the property of continuous also. Okay, so please note down this. Again, raise your hand and try to solve this in the homework. I guess you can do this question. Okay. In case you will have any doubt, we can discuss in the class and the next class. So please, and today you have test also. Okay. So I just have only 10 minutes.
Only we have to find LHD and RHD in this.
But we have to find LHD, RHD. Okay. Then what we will do, we just have the 10 minutes. So we will complete this topic right now, this question right now. Okay. And the next chapter we will start in the next class. Okay. So please try to solve this right now. They are saying it is differentiable. Find LHD, find RHD for x is equal to 1. There's no need to show the complete one. Just find for x is equal to 1. They're saying that in this question, this function is everywhere differentiable. That means it will be differentiable for 1 also. So for x is equal to 1, find LHD. For x is equal to 1, find RHD and tell me the answer. Okay. Please complete it right now. Okay, Zed. But Zed, you have test also. No issues, Zed. Then I will ask the team. Okay, okay. It's fine. It's fine. Everyone, please let me know if you have any doubt here. Okay, and Umir, please let me know if you are back. Okay. Okay, Zed. Okay, Umir, good. So Umir, we have just started this question. Please try to solve it. In this question, they are saying that this function is differentiable at x is equal to 1. Sorry, they are saying that this is everywhere differentiable. That means it is also differentiable at x is equal to 1. Okay. So please find LHD at x is equal to 1. Please find RHD at x is equal to 1 and equate these two. For LHD, we have to use second equation. For why second? LHD. This is 1. Okay. This is 1. So for LHD means you are approaching from the left side. Approaching from left side means slightly less than 1. So slightly less than 1 means 1. Check here. Here you have the value for less than 1 also and for equal to also. So you have to use this one for LHD. Okay, Afad, is it clear or you have a doubt in this one? Afad,
So it should be slightly less.
so in this case, there are both both the cases are there. This means less, if suppose, I'm just drawing a rough graph, okay? There's a quadratic equation, so it will be a parabola. So suppose the graph is like this, it is 1. Okay, if you are approaching from the left side, then you will take this portion. In this portion, you have less than as well as equal to. Okay, So if you need less than, then definitely we will use here, because in this one you have both the condition, less than and equal to both.
Okay, sir, got it.
Okay. Please check here. X is greater than 1. If you will take this case, then if you are approaching from the right side, RHD, approaching from the right side slightly greater than 1. So this represents greater than 1. That's why we will take for RHD this one. Okay. Please let me know, everyone, if you have any doubt here, because this is the last question of our topic. F1. Okay. Okay. Let me solve it. LHD at x is equal to 1. So limit x tends to 1 minus fx minus f1 by x minus 1. So we will use the first function. So limit x tends to 1 minus fx means x square plus 3x plus a minus f1. So if you will put in this function 1, what you will get 1 plus 3 plus a. Okay. So there's a variable a. Now here you have x minus 1. So we will open this bracket, limit x tends to 1 minus. So x square plus 3x plus a. Then you have 1 plus 3 is 4. So minus 4 minus a by x minus 1. So cancel out this a. What you are getting here, limit x tends to 1 minus x square plus 3x minus 4 by x minus 1. Okay, first. And if you wish, you can cancel out this further. So limit x tends to 1 minus. So this is x square plus 4x. You have both the options. Either you can put 1 minus h here and then open it, or you can solve it, then you can do this. So it's your wish. X minus 1 is equal to limit x tends to 1 minus. Take x common, x plus 4 minus 1 common, x plus 4 by x minus 1. So here you will get a limit x tends to 1 minus x minus 1 into x plus 4. This will cancel out. So limit x tends to 1 minus x plus 4. Now put x is equal to 1 minus h. This will give you limit h tends to 0. In place of x, 1 minus h plus 4. Put this limit 1 minus 0 plus 4. This will give you 5. So LHD is this. So at this step, you have the choice. You can put right now 1 minus h. Okay, and you can find the value. It's your wish. So now please complete it and share your answer. Now LHD have found out. Now please find RHD and tell me the answer. Further, is it fine now?
So can you explain the third part?
Yes.
Third step. Third step.
First again, this one. This is a quadratic equation. For this is a quadratic equation. So it's your wish. Either at this step only you can put 1 minus h. X is equal to 1 minus h, and then open the bracket and solve it. Or what we can do, we can factorize this right now. Okay, to save our time, we can factorize this So here in the denominator, you have x minus 1. In the numerator, we have further factorize this one. So this is a quadratic equation. So x squared plus 4x minus x minus 4. Okay, then we have just factorized this. We get finally x minus 1 into x plus 4. Is it clear, Fahad, or you have any other doubt?
Okay, sir.
Okay, great. So everyone, please complete it. Find RHT and let me know the answer. If anyone is facing issue in the RHT, then please let me know. Anyone got the answer? RHT? RHT at x is equal to 1. Please check here because after this, I have to take your test. So you need to find RHT. Okay, RHT at x is equal to 1. So the same thing, limit x tends to 1 plus fx minus f1 by x minus 1. So for this one, limit x tends to 1 plus. For this, you need to use the function, second one, bx plus 2. Bx plus 2 minus f1. So here you will get a b plus 2 by here you have x minus 1. Limit x tends to 1 plus. Okay, now open this bracket. So you will get bx plus 2 minus b minus 2 by x minus 1. So here you will get what? Limit x tends to 1 plus 2 cancel out. So you get bx minus b by x minus 1. Okay, we can put the limit here or you can factorize this further. It's your wish. So here, right, when x tends to x approaches to 1 plus h to 0. So here you will get limit h tends to 0. Here b into 1 plus h minus b by by 1 plus h minus 1. So this is limit h tends to 0. Open the bracket b plus bh minus b. Denominator 1 will cancel out, you have h. B will cancel out, so you have here limit h tends to 0. bh by h. H will cancel out. Limit h tends to 0. B. So there's no h, so final answer will be B. Okay, so Abdur, Fahad, Omer, Rifat, Zad. This is clear. RHD is B. Abdur, Fahad, Rifat, Omer, and Zad. This is clear. RHD. RHD is B in this
Sir, in
case.
the second step, you wrote 21.
No. Oh, sorry. Yeah, this is nothing. Okay, thank you. Okay, that was not a 21. Oh. Okay, okay, Rifat. Fahad, Umair, Saad, Abdul. Is it fine?
Yes, sir.
Okay. Abdur, Umair.
Yes, sir.
So
Okay, great. So please note down this. Equate LHD and RHD, you will get the value of B. Okay, now tell me what the value of B you are getting. Anyone can tell me what is the value of B here? This is the last question, then your class is over. Okay, tell me what the answer you're getting. What is the value of B here? No one? Well, they're saying it is differentiable. So equate LHD and RHD. Can anyone tell me what is the value of B now? Abdur, is it clear?
Yes, sir.
Okay, so what the value of B you will get?
So 1.
Why 1? What is LHD? What is LHD in this question, Abdur?
So 5.
5. What is RHD?
So B.
B. So what's the value of B?
5.
5. Okay, so please write fx is differentiable at x is equal to 1. So LHD is equal to RHD, 5 is equal to B is equal to 5. Okay, now the next point is how you can find the value of A. Okay, please note down this, then raise your hand so that I can help you in finding the value of A. Okay, please raise your hands once it is done. Is it done? Abdur, Fahad, Umair, Rifat, Saad, this done? Okay, Saad. Okay, Abdur. Okay, great, Saad, good. Fahad, Umair, Rifat, is it done? This question is clear. I guess you do not understood this question properly. Is there any doubt in this question?
So value of A.
Sorry,
So what is the value of A?
what the value of A? Yeah, that I will tell you later on. But before that, everyone understood and noted down this question. Fahad, Umair, and Zad. Sorry, Zad. Fahad and Umair. Fahad and Umair. Is it done?
Yes, sir.
Okay,
Yes.
great. Umair. Okay. Okay. Now, what the value of A? Okay, we have used the concept of differentiability. We get the value of B. So fx is differentiable. It is given in the question. So we will use fx is differentiable at x is equal to 1 and x is equal to 1. So LHT at x is equal to 1 is equal to RHT at x is equal to 1. Okay. So here you will get a 5. Here you will get a B. B is equal to 5. Now, how can we find value of A? Anyone can tell me how can we find this value of A? Any idea? No. Okay. So shall I erase? I'm going to erase this. Okay. Now, this function is differentiable, Fahad. So can we say that this function is also continuous? True or false, Fahad?
True.
True. Okay.
Yeah.
Okay. So we have discussed this yesterday. Fx is differentiable. Fx is differentiable at x is equal to 1. So it is also continuous at x is equal to 1. Okay. So that means we can use the concept of continuity here. Abdur, when what is the condition if a function is continuous at a point? For example, if this function is continuous at x is equal to 1,
So f of x equals to f of A.
f of x is equal, sorry, a is equal to limit x tends to a. This is the condition. Now for continuity, what we say, this limit x tends to a fx is equal to fa. Is it clear, Abdul?
Yes.
Okay, so for this continuity, we have this condition. Limit x tends to a. This is your last topic, okay, of this chapter. So please focus here. So limit x tends to a fx is equal to fa. Hence, we can say here limit x tends to 1 fx is equal to f1. Okay, now here we have an inequality. That's why we'll find the left hand limit and right hand limit. This means limit x tends to 1 minus fx is equal to limit x tends to 1 plus fx is equal to f1. Okay, now find LHL. LHL at x is equal to 1. So what you will get here? Limit x tends to 1 minus fx. Okay, limit x tends to 1 minus. For 1 minus, who can tell me? First, for 1 minus, which function we will use? First or second?
First one.
First one. I think this is not clear to you. Anyone have a doubt here? This is not clear. Shall I leave it and we will do this next week?
So you can continue.
We can continue. Okay. Okay. Then put x is equal to 1 minus h. Then limit h tends to 0. Here write 1 minus h whole square plus 3 into 1 minus h plus a. In the bracket write when x approaches to 1 minus h to 0. Here put this value. So 1 minus 0 whole square plus 3 into 1 minus 0 plus a. This is a not 9 plus a. So what you will get here, 1 plus 3 plus a. So this is equal to 4 plus a. Okay, in the same way, please note down this. In the same way, we will calculate RHL. So I will do RHL here. I will find out RHL here. Okay, so RHL at x is equal to 1. So what is RHL? Limit x tends to 1 plus fx. Now this is equal to limit x tends to 1 plus, we will use the second one, bx plus 2. Put x is equal to 1 plus h. So you will get you will get limit h tends to 0. b into 1 plus h plus 2 when x approaches to 1 plus. B into 1 plus 0 plus 2. So you will get a b plus 2. Okay. Now we know that LHL at x is equal to 1 is equal to RHL at x is equal to 1. Okay, because it is continuous and limit exists. We have already written this. What the LHL you are getting 4 plus a. What the RHL you are getting b plus 2. What is the value of b we find out in the previous slide? 5. So 4 plus a, 5 plus 2 in the bracket, write b is equal to 5. So this is a is equal to 7 minus 4, a is equal to 3. A is equal to 3. So please raise your hand who understood this. I have a feeling that in this question, you have a doubt. This question is not clear to you. Please raise your hand if this question is clear to you. That means no one understood this. Okay, then please please note down this. Okay, I will again explain this to you. No, it's fine, Umair. It's fine. Okay. So I will explain this to you again in the next class. Okay. Now you have a test. So please note down this. I will again explain this to you, and next class we will start. I have to go. Yes, yes. That's fine, Umair. Please note down this. Okay. Then we will start our test, and then in the next class we will again discuss. All of you, please raise your hands once it is done. Shall I raise this? In the next class, I will explain this to you again, the complete question. Is it fine? Okay, I'm going to erase this. Okay. And in the next class, I will do from the beginning. It's fine. It's fine. Okay. Okay, then all of you, are you ready? Shall we start the test? Okay, I'm going to change this.